And also it's my honor to introduce our last speaker in our seminar series this semester, Professor Joe Cutcher-Gershenfeld.
Perfect.
Joe is a professor and a former dean in the School of Labor and Environment and Employment Relations at the University of Illinois. And he also holds a current appointment in Industry and Enterprise System Engineering. Here, this is a systems seminar, and we tend to kind of emphasize, the engineering part, because system, we realize it's not only engineering but also social science. But so we have quite a range of audience here. Joe is, he has been the author of many award-winning books. I just list a few. Maybe some of might be new to you. Multinational Human Resource Management and Law. And another one, the human side of enterprise, valuable disconnects in the organizational learning systems. In Joe's current research centers on stakeholder alignment of complex systems, which I think he's going to talk about. And I was talking to Joe. I'm personally very interested in this area. Joe was the 2009 president of Labor and Employment Relations Association. And prior to coming to University of Illinois, he served as director of Engineering System and Learning Center at MIT, and also he visited I think Bascom College as a visiting associate professor. I don't know what time, but I think probably a long time ago. Yes, I think it's really a pleasure to have Joe here. So,
well, thank you. Thank you so much. I'm honored to be here. And what I'm going to do is really share with you some different slices into research on this emerging and central issue of stakeholder alignment in complex systems. Briefly, I'll share with you some overall principles. We're going to then take a close look at stakeholder alignment in the area of community green energy. And we'll look at stakeholder alignment in the area of the science of science, focusing on the cyber infrastructure for the geosciences. And then we'll wrap up with some causal modeling that we're starting to do to understand the phenomena in a deeper way. And then, of course, we'll open it up for questions and comments. But to begin, I'd actually like to start by telling you a story. A number of years ago, while I was in the Engineering Systems Division at MIT, one of my colleagues in AeroAstro, Ian Waits, who's now the Dean of Engineering at Cornell, was approached by Congress to see if something could be done about aircraft noise and emissions. As some of you may know, there had been, I think, 17 different studies over a 20-year period on aircraft noise and emissions, and legislatively there had been gridlock. Nothing had been done, and in fact, as a nation, the government was spending about $500 million on noise and emissions, all of which was going to insulate homes near airports. Not really a system solution. So none of the money was going to the next generation of fuel-efficient, quieter engines, new flight paths for descent into airports, or any of the other things that might be system solutions. Instead, we were putting Band-Aids on the problem. So what did we do? Well, I was part of a team that Ian assembled, and we identified approximately 42 types of stakeholders: airports, communities, airframers, engine manufacturers, and so on. And we interviewed 1, 2, or 3 representatives of each type of stakeholder to understand their interest relative to noise and emissions. And we then brought all of them together, a group of about 40 or 50 people, for a 2-day conference to sort of get the sense of the group. Based on that, we wrote what we intended to be a consensus report and circulated to all the participants, and instantly got almost 300 responses back of things that we needed to be changed, emphasized, or what have you. We worked up a revision of the report and brought people together about 2 months later for a second 2-day gathering. And it was at the second gathering that I saw the intersection between my background in industrial relations and the work in engineering systems, because as I was watching the room, I realized that what was going on was collective bargaining. The airline said we would go to a new generation of engines, but many of us are on the verge of bankruptcy. The engine manufacturers said we'd be delighted to sell and develop them, but where would the resources come? and people said, well, we could put up some money if this were to happen and that were to happen. And there was genuine negotiations going on. And at the 11th hour, on a couple of issues in which there was just logjam, the EPA, which had been a reluctant partner, came in and actually did some things that needed to be done. And so we took all that into account and produced a revised report. And in fact, it was a consensus report that went to Congress. And based on that, 6 working groups were set up as part of the Next Generation Air Transportation Initiative. Those groups are still functioning now. Some areas involved new science on the effect of contrails on the atmosphere. Some involved actual design of experiments and any number of initiatives. And some involved setting standards and policies. And that, too, has taken place. Why do I tell the story? I tell the story for 2 reasons. One, it illustrates a fundamental principle that I'll be sharing with you, which is the role of stakeholders and interests in complex systems and learning new ways to think about them. But it also illustrates an underlying principle here, which is that in most systems on the social side, it's easy to be negative, and the likelihood when folks are negative is you get gridlock. And it's hard, but not impossible, to have people take a positive, constructive approach and to have it lead to transformational outcomes. So with that in mind, let me take you on a journey. And actually, I'm going to ask you, I wish these seats had seatbelts, because we're going to be covering a lot of different territory. We're going to start in France in the 1450s. That's where you usually start in your seminars. This is a tapestry from around the 1450s. It illustrates the church, the state, the military, institutions. And the reason I have it here is that around this time, the word institution was coined in French, circa around 1450. And I say that because it's illustrative of the very slow pace of change of technology and institutions, that things like the church, the military, and the state were in existence for 500 to 1,000 years before there was even a word in French for them. And there was no other Western languages had a word. They all came from French, which came from Latin. But that's the first thought. Let's go forward to the Industrial Revolution. This is the shop floor of the Auburn Motor Company. How many of you have heard of Auburn Motors? I know at least one person, me too. What do we know about Auburn? They made pretty good cars, right? Yeah. The Auburn, the Ford, yeah. If you go to Auburn, Indiana, you can still see their museum there. At the time of this picture, which was around 1905, there were 140 car companies just in the state of Indiana. They were all carriage manufacturers trying to become car companies. And some of them got it. They got the idea of interchangeable parts. They got the idea of an assembly line. This is axle assembly. They didn't get the idea of the moving assembly line. They're going from sawhorse to sawhorse. And the reason I have this here is twofold. First, at that first industrial divide, those folks that got parts of the new model but not the whole model have become footnotes to history. 3 hands in this room, and very few people really know the folks that didn't quite get the new model. But the second reason for showing this is that with the change in technology, the pace of change in institutions accelerated. In 50 to 100 years, things like unions, political parties, constitutional monarchies, Lions and Elks clubs, lots of different institutional arrangements came into existence at a much faster pace. And that really sets the stage for today. This is a quote from Eric Trisk, one of the founding socio-technical systems theorists, who argued that we're moving to a different kind of society, a post-industrial society, what Peoria and Sable called the second industrial divide. And he says, by the way, cautiously, there is no guarantee of our safe arrival. But he also says that the interdependencies are greater, they're differently structured, and they demand a new mobilization of the sciences. And that's really the deep underpinning of what we're trying to do here. I would argue that in this post-industrial world, the pace of change for institutions has accelerated by another order of magnitude. So in 5 to 10 years, or 10 to 20 years, the entire institutions can change under our feet. And so how do you have agile institutions when they don't even span a lifetime? They can change dramatically. Take higher education, the institution within which we reside. We don't know what the massive online courses will do, or the private sector players, or any of the others, but the impacts are being felt measured in years, not decades or centuries. So with that in mind, the second argument that I want to make is that most of the complex engineered systems that we have in society have social systems, institutions attached to them that are poorly matched to the accelerating pace of change in these systems. As a background, I used to co-teach the doctoral seminar in engineering systems at MIT, and we would ask our doctoral students to pick any complex engineered system of your choice. These are just some examples. And find 20 examples of systems-level data. And of course, what they found was, A, it's hard to find systems-level data on complex systems, but even more so, we count things that aren't necessarily the most important things. And so how can you lead a system if you don't even have the data to guide you? And that's the deep driver for what we're doing here, is to try to develop the tools and the data on the social side to understand and lead institutions to govern these systems. Now, the National Academy of Engineering has a list of the top 20 achievements of the 20th century, and I would argue that in every single one of them, the institutions were forged on 20th century or even 19th century models that are incompletely matched to the requirements of the 21st century. So, what are the requirements of an institution in the 21st century? I would argue that the requirements haven't changed since 14th century France. That at a basic level, institutions need to do two things. They need to mitigate harm, and they need to create value. The difference when you have an accelerating pace of change is that the old model of mitigating harm was how to minimize externalities. The new model is still to take into account externalities, but also how to prevent catastrophic system failure. And of course, the Sandy storm in New York is a classic example of not just of a natural disaster, and the financial collapse a few years earlier is a man-made disaster. Both are cases where we encountered some system successes, but also evidence of the system itself being on the table at risk. And the other thing is to create value. And the old model was expanding the pie. Increasingly, creating value also includes transformation, periodically fundamentally changing the system to take into account advances in technology, changes in society, and other kinds of shifts. Not only that, but one of my colleagues at MIT, Joel Moses, reminds us that systems have properties, what he refers to as the illities. And so not only do you have to create value and mitigate harm, but you have to balance the importance of stability with agility, the importance of scalability with sustainability. And these are all properties that involve balancing. You can't optimize on all dimensions at once. So I want to further motivate the journey that we're on with the words of Elinor Ostrom. She received, of course, a Nobel Prize for her work in institutional economics. And her main point was that with common pool resources, the things that systems have to deal with, for the most part, either people would recommend government intervention or private market solutions. And what she found in water management, in remote villages, and other places were folks that had formed hybrid institutional arrangements that were neither purely regulatory, although they involved standard setting and some oversight, nor were they purely market-driven, although they involved some independent action and behaviors. She recently passed away this year, and her great regret was that even though she was sure that there were hybrid institutional forms that could exist to govern common pool resources, the things that she had found didn't seem to be scalable. And so part, again, of the motivation of this is how do you understand scalable institutions that match to complex systems on the scale of even societal infrastructure. Now, so far, we've done the aviation environment study that I mentioned. I'm going to share with you results from a study that we've done on community green energy, and a little bit on the biomarkers biomedicine study that we've done, and quite a bit on the geoscience research that we're doing. These are all the studies that we've done so far. or that are in process. And so it's still the early stages of figuring out how do you study and measure systems at a systems level to understand stakeholder alignment. Let me first begin by defining my terms. We define stakeholder alignment as the degree to which interdependent stakeholders, independent but interdependent stakeholders, orient and connect. That is, do they see each other? Are they working together to advance both separate and shared interest? If it's just separate interest, it's a market solution. If it's just shared interest, it's either altruism or a government intervention. This is a both and. And when we talk about alignment, we're talking about behavioral alignment. That is, do the stakeholders in these systems trust each other, talk to each other, engage with each other? So there's a lot of behavioral stuff about communications and attitudes and affect. There's also structural alignment or misalignment. Are the incentives and the forums aligned or misaligned? There's strategic alignment. What are the strategies of the different stakeholders? Are they pointing against each other in parallel paths, in complementary ways? And there can be cultural alignment or misalignment among stakeholders in a complex system. My friends in industry say that culture eats strategy for breakfast. And so when we did that study with aircraft noise and emissions, the folks from DOD would say to the group, well, you do this, you do this, you do this, and everyone would say, well, it's good that you think that way. But that was the DOD culture. The EPA culture was a regulatory one. The FAA culture was one of the partners for industry to run the system. So just among the federal agencies, very different cultures. And to figure out how to get alignment is, in fact, the challenge in these new working groups that have public-private partnerships. Further, from the case studies that we've done, there's some things that we can already say. So the main finding and the main motivation for what we're doing is that if you make the interests of the stakeholders visible to the stakeholders, you increase the speed with which you can do institutional change and move initiatives forward. I was at the industrial relations meetings this summer, the international meetings. David and Harry were both there. And coming out of my room down the hall, there was a fellow who was at the meetings from Greece. He was a labor mediator. And we were talking, and I said, boy, you've got some big problems with public sector labor relations in Greece. It's kind of the heart of the whole crisis. And he was sharing how challenging that was. And I said, to what degree do the stakeholders in Greece understand each other's interests? And he literally grabbed my arm. He said, that's the issue. They don't. They don't. They make assumptions. They don't see where each other's at. And that's exactly the journey that we're on, is how to make the interest visible at a systems level. One finding that we found is that, of course, if you can build a shared vision, emphasis on the word shared, of success, the chances of getting alignment is greater. You ask people in 3 to 5 years, what would success look like? And it's helpful. Something that I'm going to take a deep dive on with some of the multivariate analysis is what we call lateral alignment, internal alignment for lateral alignment. It goes back to Walton and McCursey, a classic behavioral theory of labor negotiations, which argued that there's intra-organizational bargaining, such that in labor we say it takes 3 agreements to get one, within the union, within management, and across. We're going to now apply that to end stakeholders, where each stakeholder needs to have internal alignment to do lateral alignment. We found that the alignment begins with trust among individuals, but ultimately you need reinforcing structural things. Just behavioral alone won't do it. Leadership in these systems, because no one is in charge, we're not within the 4 walls of an organization. There's not a single hierarchy. Leadership is based on influence more than authority. The old socio-technical systems folks used to say that when you're designing a system, you don't want to under-specify it or over-specify it. And if the forums become too bureaucratic, they don't work. But if they don't have enough of a clear charter, they also will fall. One of the most powerful levers for change at the systems level are in protocols and standards. The classic change models are either top-down change, re-engineering, or bottom-up process improvement. But in a large distributed system, there is no top-down per se. There are some things that you can re-engineer in a central kind of way, but that's limited. The bottom-up is crucial for innovation and energy, but if it's not well-directed, it can go in a lot of directions. So, the classic example with the internet is the role of TCP/IP as a standard. once you set the standard for how people connect with each other, then a whole lot of other things can happen. Getting the protocols and standards right is high leverage in these systems. And the bottom line, it's back to our definition, it has to be this both ends. People have to get results for themselves and the collective. Now, this is a challenging area. Even figuring out how to classify systems, layers, components, and interactions, how to develop and test causal influences when these are mostly one-of-a-kind systems in which the outcome is not determined. And there are issues around data collection. I'll show you what we've been able to do. But here's the core thought. This is the thought that sort of crystallized our work, which is that you can conceptualize a system as a matrix. This is a heat map in which we have, this is from the Community Green Energy Study. You'll see that we've improved the visualization, but this is 12 sample stakeholders. This is 45 sample interest. So on each interest, you have a vector of stakeholders, and for each stakeholder, you have a vector of interest. And the point is, and we color-coded them, so if they're negative on an issue, it's red. If they're positive, it's green. And here's the key, is that once you conceptualize the system as a matrix, you can then take any given stakeholder and say, what does the vector of interest that they have look like, and how much variance is there, and in a sense, measure alignment of that stakeholder relative to all the different issues. Or you can take all the stakeholders and say, for a given issue, who's aligned and misaligned. And again, we're doing baby steps, but I'm going to share with you some early analytics to begin to think of systems in this way. But this is the core building block. Once you have the matrix mapped of the system, there's a lot that you can do with it. Cautionary note, these are still early findings, early research, so things are still in motion. But I'm going to start by introducing you to our visual tool. Now, the way the tool works is, imagine that you have lots of stakeholders. We assign them each a hexagon. Hexagons we picked because they're easy to tile. And we color code them by their responses on a given issue. This one is negative, this one is more neutral, this one is more positive. And you can array them. Let's say we normalize the data for a lot of studies now on a mean of, with a range of 0 to 1. So a negative view might be 0.2, a positive view might be 0.9. You can calculate a mean, and you can even array them, those that are above or below the mean but that are closest to it, versus those that are above or below the mean that are further away. And what we're going to do is we're going to take these interests and we'll put the mean in the middle, and we're going to tile the stakeholders with the ones that are closest to the mean closest and the ones that are literally the outliers on the outside edges. We call them a Z-flower because sometimes we use Z-scores. But the key point is that there's this spiral of interest going out. The white cells are non-responses. So if every stakeholder is a hexagon, so part of this is that every stakeholder's view matters. If everyone is positive on an issue, the Z-flower will look like this. If it's a bimodal distribution, the central tendency, which is the middle, is yellow. The outliers are all positive, but it's bimodal. This is a mixture where the central tendency is kind of neutral, and the outliers are both very negative and very positive on this given issue. And it's kind of like a histogram, but where every stakeholder is represented, and it's color-coded so you can see what's positive or negative, and to get a quick thumbprint of where folks are at on an issue. Now, let me show you first using traditional means and then the Z-flowers on what it looks like for community green energy. This is just a network map of these different stakeholders. The size of the circle is how dependent other stakeholders are on them. The arrows are how frequently they communicate. I think G is the University of Illinois. I won't go into all the details of this, but I just wanted to give you a sense for the array of stakeholders at a community level associated with green energy. We asked them, usually 1 or 2 representatives of each stakeholder type, how important is it in this region? Where do we stand now, and where would you like to be in 3 to 5 years on solar, biomass, wind, smart grid, geothermal, and energy conservation? And needless to say, on a scale of 1 to 16, the current state is sort of not so great, but not terrible. but the future state, there's always a gap that people can imagine things would be better in the future. We also asked them about sort of some of the social relations. What's the communications among stakeholders? What's the consultation? What's the degree to which they're aligned on a shared vision, and so on. And here, the means are quite a bit lower, that people are saying that there are problems with the current state, but their desired state in 3 to 5 years is quite positive. Now, just with those data, you can do some very simple analytics. So, for example, you can calculate the coefficient of variation by taking the standard deviation divided by the mean, and basically, if you get a very small number, it means there's a big gap and not a lot of variance. And if you get a big number, it means there's not as much of a gap and a lot of variance. The interesting thing is, when we did this study, the University of Illinois and GE had spent 2 or 3 years trying to build a wind farm on the campus. The university had the land, it had the money, and there was all sorts of community protests, and it never happened. And if we had done this study previously, we could have told them wind was the last place that you want to start, because there was, variance in views. And that, in fact, if you start with communications, consultation, solar, and smart grid, and now the smart grid initiative is really taking off, you would have a better chance for progress at the community level. But here's the Z-flowers, and this now gets you into the visualization tool. Same data that you saw in the means, but now you see every stakeholder's view on solar, wind, geothermal, and so on. And what you see is that there are 5 stakeholders that were very negative on wind. There are quite a few that are positive. But what's interesting is when we go to the future state, how could things be in 3 to 5 years, there are still 4 stakeholders that are quite negative even in 3 to 5 years. And so you begin to see that even if the mean wasn't that different, that the variance is really where it's at. Are there folks at the extremes, positive or negative on an issue, and how do you deal with that? So the visualization is meant to be able to see that landscape. When we ask people about how do you feel about learning about distributed energy, about smart grid, about research opportunities, everyone was in agreement. So for the community leaders, when they saw this, this is apple pie. These are the issues that you can get up and say, everyone is in agreement. When we ask them back to those issues of trust and transparency, this is the data that we saw. And literally, when we presented this to the city councils of Champaign and Urbana, people got out of their seats and said, oh my God, this is the work that we need to do. Because they could just see visually, viscerally, in a way that the means fully didn't convey, that there's some folks that feel quite negatively. Let me pause here for a minute. That's a brief introduction to the community green energy findings. I want to emphasize a point that comes from Lean and Six Sigma thinking. This is a hypothetical dart game. You get points for being closer to the middle. In this round of the dart game, who has the higher score? One on the left or the right?
Left.
The left has the higher score. There's more darts closest to the middle. Who would you rather coach on how to improve? You know exactly what to say to this one. If you say, here, go up a little, go down a little, you're just going to get more noise. And so when we do the stakeholder alignment work, we're looking at variation. We're looking at how much variance there is in the system, because the fundamental principle from Lean Six Sigma is you reduce the variance before you improve. And in a sense, we're saying, how can you do that, understand it at the level of stakeholders at the system level? Let me pause here for a second. I'm going to take you now into the work that we're doing with the cyber infrastructure for the geosciences. But are there any questions on that so far? Yes.
Well, I'm really interested in the way you're measuring the interests that
Yes.
go. And one of the things that happens in these group processes is group learning and greater definition of what people's interests are. So I'm wondering, in other words, interests aren't necessarily fixed in time. So
Yeah.
I'm wondering how you
It's a great point.
account for that.
We make a couple of core underlying assumptions. We assume that people have both common and competing interests. And we assume that interests are not structural and defined in a fixed way, that it's negotiable. So, in fact, the tools that we've developed are designed to do repeated measures and to add more questions and to take out questions over time. That's exactly what we're now doing with the geoscience study. Because if we're successful and people see the interests, then they will say, okay, this is now no longer so important. We're going to reframe this. Equally important, and I'll say a little bit about this later on, the process that we follow first involves specifying the stakeholders. And it can take 2 or 3 weeks with knowledgeable informants to figure out the right granularity. Typically, it's somewhere between 10 and 30 types of stakeholders in a complex system. You could sub-specify it into 300 or 400 or down to 2 or 3, but generally 2 or 3 is not finely grained enough to be meaningful, and the other is just overwhelming. After you specify the stakeholders, then it's identifying the interest. And in most of these systems, there's about 40 to 60 in real-time interests that are on the table at any given time. And the real art is being not leading the jury, coming up with questions in a survey that people say, yes, that's a fair way to ask the question about these interests. And then you're absolutely right, that if you're successful, there will be these negotiated interactions such that the very definition of the interest evolves over time. So
how do you define stakeholder?
It's a really good question. In general, the definition is those individuals or groups of individuals who have a stake in the outcome or operations of the system. By itself, that doesn't tell you much. And so it really becomes very much part of the conversation. So, for example, in the geoscience research that I'm going to share with you, the first order definition of the stakeholders are all the fields and disciplines of the geosciences that need to combine together to do transformative work on climate change and other issues. Other stakeholders include politicians, include educators, and so on. And for the first round of the research, we're more focused within the fields and disciplines, but for future rounds, we're going to widen the net. So, in a sense, the definition of the stakeholders begins with, well, what are the system-level issues that you're trying to address? And then there's this iteration between what are the interests, who are the stakeholders? Well, if that's your definition of the stakeholders, are there some other interests that we need to think about? If those are the interests, are there some stakeholders that we need to think about? So I find that the definition of the stakeholders involves iteration back and forth before you can say, yes, these are the useful categories for analysis. Ready? Yes.
So I have a question, comment that you might want to delay, and that is, if you're using this to sort of describe or analyze systems, it also seems that you could use this or test it or draw parallels between it and politics, right? So I was thinking, you would think political scientists must do something like this. I don't know exactly what they do. I'm not a political scientist, but I don't know. When they try and understand gridlock in decision-making within Congress. And I was wondering whether there is a parallel literature or application, or whether you might also have you or students who take this framework and just literally apply it to voting behavior and coalition building within Congress or some other.
So the short answer is yes. In fact, so there's a literature on stakeholder alignment in corporations, which is very much of a corporation out stakeholder view. So it's from one company's point of view, who are the stakeholders that you're affecting with some new initiative, and how do you get them to do what you want to do? So it's sort of a unicentric kind of approach. We're trying to take much more of a neutral ground towards multiple stakeholders. In political science, there is a literature, of course, on this area. Some of it is game theory driven, some of it is decision science oriented. I did have a PhD student at MIT, for example, apply this approach to the Federal Reserve Bank and its setting of interest rates. There are a lot of models that try to model and predict interest rates, and they usually do pretty well, but it's like mid-90s in terms of percent accuracy. He took 40 years of Federal Reserve notes and basically studied coalitions and interests that were at play, and got over 99% accuracy retrospectively. Unfortunately, the minutes don't come out until sometime after the meeting, so it's hard to do it without the minutes. But the point is that it worked incredibly well. So it's a really good point. Yeah.
Isn't it a critical assumption in the model that you've described so far that you give equal weight to every stakeholder group?
Oh, what a good question. So we're taking a neutral view in terms of the visualization. In fact, some stakeholders are more powerful than others. And we're developing ways that you can sort of lift out certain hexagons to see them different than others for any kind of variable, whether it's a demographic variable or a power or an influence variable or others. But I think you do need to say whether those 4 squares that were negative on wind energy are powerful players or not. And so the role of differences in power is certainly something that we want to figure out how to wrestle with.
Not to go too far with this, but do you have a definition of power? We know there are a number of them.
There are lots. In general, what drives this work is that we strive as hard as we can to represent the issues in the words of the stakeholders. And so the power of this is that you're presenting back to people where others are at in their own words, and words that have face validity. And so I would say that the way we would define power is by asking people who has power, and not try to impose our own definition, but do it sort of in their own words.
Are you gonna? You had mentioned in your introductory remarks some, about lateral and internal alignments.
Yeah.
And are you going to get back to that?
I'm going to come back to
it. Okay,
good. Mindful of time, maybe I should move forward, but these are excellent questions. All right, in 2009, the head of geosciences and the head of cyber infrastructure at the NSF joined together to issue a report saying that the fundamental challenges, the big grand challenges facing the geosciences, such as climate change, couldn't be resolved with the existing cyber infrastructure. That is, there's data, tools, models that need to be shared across fields and disciplines to solve the big problems. It's part of the larger shift in the sciences from discipline-driven science to problem-driven science. And how can you create the cyber infrastructure to support it? The initiative that emerged is what's called EarthCube, and it's basically designed to take all of the aspects of Earth and life on it and have it available as a integrated cyber infrastructure. This initiative is about 1.5 years old. We had done the studies on green energy, on biomedicine, and on regional innovation. And last January, I presented that at the NSF, and there were people from EarthCube in the audience, and they instantly said, this is what we need. It was pretty wild. I think I told some of you that they called us the next Wednesday and said, get us a proposal by Friday, and we had authorization to spend on Monday. And we've since been given one of these new Inspire Awards. The director of the NSF has issued 40 awards for things that are cross-directorate and transformational in nature, and that's what's now funding the work that we're doing. Basically, in specifying the stakeholders, we identified these as the critical ones in the geosciences, plus these others. Most of what I'm going to do is going to focus on this group here. I tell you, we spent 2 or 3 weeks. This list could have been twice as long with subfields and subdisciplines. It could have been shorter, but this is sort of what we focused on. And just to give you a sense of the data, we've now surveyed 809 geoscientists and others. NSF has about 20 major data centers. We push the survey out to them. It's like NCAR that does atmospheric research and others to the data centers. We have no idea what the actual population is because there's many people at the data centers who are not geoscientists but also use that information. The EarthCube website, we had about 123 responses, and there have been starting to be what they call domain workshops. I helped to organize one for early career scientists, and so far there's been a tectonics and an Earth scope workshop. There are others that are coming up, about 14, and we're collecting data from all of them, but I'll give you some results broken out by these groups as well. But the first group of respondents that you're going to see are those that don't know much about EarthCube, which we consider to be the general population of geoscientists, versus those that are somewhat involved. And Just as a background, most of the responses are from the geosciences, but there are some computer science or cyber people. It tilts towards more experienced folks. Most of the folks are in U.S. institutions, but you'll see there's some play on the international. The field is approximately 70-30, male-female, and this is the mix of settings where people responded. So that's the data that we're pulling on, and here's the rough distribution. It's a bit of a large array-based data-centric set of respondents that's heavy, partly because we have the domain workshops in there, but this gives you the sense of who we're asking these questions for. And by the way, I said that you can get level below of specialty beyond the 10 geoscience categories. This is just a rough sample. When we ask people, what's your specific area of expertise, out of those 800 respondents, I probably have like 700 responses like this. And so when you ask people to collaborate on big climate change issues, it's not just can the hydrologist work with the geologist, it's can the metascale meteorologist work with the carbonate stratigraphers and so on. And by the way, I do know who this person is, and he's right, it is. But in any event, that's part of the challenge in terms of you asked how do you define stakeholders. Well, you can go to different levels of disaggregation. We also ask people what's your primary field and what's your secondary field, and we haven't even started the analysis of the hybrids that are primary and secondary. But that's all part of mapping the territory. Now, you can use a bar chart. We ask people, how important is it for you to share or find data, tools, models from within your field? And how easy is it? The central question in terms of, this collaborative work, and how important is it to get data from across fields, and how easy is it? And if you look at this chart, what do you notice? So the blue is within your field, how important is it? The light blue is how important is it across disciplines, and the dark red is how easy is it within your field versus how easy is it across disciplines. What do you say?
There's a lot of perspective that says cross-discipline is important.
So the first thing is that, we've been saying cross-discipline. If you look at every NSF solicitation, it says cross-disciplinary scholarship. Well, the evidence here is that people are saying, that the vast majority of folks are saying, almost as high as within your field, that it's important. So there's some strong base level support for importance. But the other thing, of course, is this gap. And that's the motivation for EarthCube. So this is one way to visualize the data. It's useful because you can show a lot of data on one chart and see a lot of relationships, but it doesn't let you see the full distribution. And so here's the responses. Again, these are the same means that you saw in that chart. And here's the Z-flowers for everybody else in terms of importance. The EarthCube active folks, the early career folks, I just put up the three. And you can see the vast majority of people are saying it's important, but among the outliers, there's some that are a little bit more neutral, and some that are just using their own data, or just saying that it's not important. But then when we ask how easy is it, you instantly see the contrast. And that's the point of this visualization, is to be able to create that visceral sense of the gap. And so this helps you to see that there is that gap, and some of the outliers here are quite negative. But notice there are some folks here that are green. And in change theory, we talk about bright spots. And so some of those folks are saying, it's easy to get the data I need to do, so we need to understand those folks for whom it's working. When we ask how important is it to go across fields and disciplines, again, it's pretty positive, but the gap, of course, is even greater. So when we show this to the EarthCube folks, this is an instant sort of case for the need for this infrastructure. It's important to do, and it's not easy. By the way, I did measure the gap between importance and ease, and you can see that for all of the areas of science, the gap is a 0.4 or more on a scale from 0 to 1. So that's a pretty big gap. But it's highest for the critical zone scientists, which makes sense. Critical zone is a field that's less than 10 years old. It's at the interfaces of land and water and air. It's the critical zone where life happens. There's only 5 critical zone observatories. They're only 5 years old. So it's an area where things are still quite new. But again, this is just the beginning of being able to create analytics to understand where the path forward is. We asked how adequate is the current suite of tools, and people said there's problems. We asked people qualitatively, what are the barriers to sharing data? And when you look at this list, what do you notice? How much of this is social, would you say, and how much of this is technical? This is in priority order of the barriers to sharing data, tools, and models.
Half social.
What?
Half social, at least.
Yes, so there are both social and technical things going on here. EarthCube, if it's successful, will help with this. But what does it tell you about what it will take for EarthCube to be ultimately successful? In a sense, it will take
A lot of institutional
What?
transformation.
A lot of things will have to change.
Yeah,
Transformation.
it will take institutional change. Take this one. When we did the early career workshop, we were talking about the importance of sharing data and so on. We, by the way, went to 42 NSF program officers and said, pick the top 3 assistant professors or postdocs that you seek up and coming. And we invited 150 people to the workshop. 72 came. And it was an amazing collection across fields and disciplines of talented people. I was showing this data, and one woman got up, and it was like an AA meeting. She said, I just realized I'm a data hoarder. But then she went on to say, you know, I've got 4 years till tenure. I finished a study. I've cleaned the data and done enough documentation for my purposes. It would take a couple more months to clean it and document it so that others could use it. Is that the best use of my time between now and tenure? My senior folks are telling me no. And it led to a conversation to say, if you had a DOI, a data identifier, that let you track when other people are using your data, so you could get like a citation count like we do with people who cite your work, and you could say when you're coming up for tenure that these 3 other studies use my data, that might have more weight than, you know, just serving it up for the common good. And so it really raises issues that behind this are institutional arrangements that need to adjust. At the University of Illinois, we did change the tenure standards to specifically list cross-disciplinary and translational work as part of the standard. And if you have questions, I can tell you how we operationalize that. That's less than 5 years old. But the institutions are on the table in order to make the technology achieve its full potential. By the way, we asked how much do geoscientists cooperate and share data and software and tools, and the answer is not so much. We asked how much do the cyber folks, the computer scientists, share software, middleware, and hardware, and the answer is not so much. So again, it's back to these behavioral issues. We asked how much do geo and cyber cooperate together, and the answer is even less. We asked how much is there end-user training in the tools and use of the methods for sharing data and software, and the answer is much less. So again, this is sort of the current state map. Over a 10-year period that this unfolds, we expect to take measures every summer, and we want to see these numbers move. Now I want to shift gears because I want to take you into the other data that I was going to tell you about, the analysis of the internal and lateral alignment. But to do so, I want to motivate it by actually going back to Mary Parker Fulham. In 1933, as a female economist, she gave the inaugural lecture at the founding of the London School of Economics. And what's really important is what she had to say at that lecture, because she introduced the concept of integration to our language in the social sciences. What she said is that you can resolve disputes by domination of one party on the other, and you get winners and losers. You can resolve disputes by compromise, in which case no one really wins. Or there's this third way of, in a sense, taking into account the interest to create something new, the idea of integration. And the whole spirit of this enterprise is to make the interest visible so parties can find the integrative solutions forward in this space. Now, when we ask people among the geosciences, does your employer value, or will they value your work with EarthCube? Will your organization see this as integral to your job? Will your colleagues see this as integral? Right now, people are saying no. And this is something you'll see with the additional analysis that really worries me. Because these are the measures that we have for the internal alignment for lateral alignment. Will the internal workings of your institutions support you to reach across in new ways? By the way, when we ask, will this substantially change your capabilities, people are cautiously optimistic. I'm going to go through this pretty quickly because I want to get to the next thing. People did give us elements of a vision of success. Again, I won't spend time on this because I really want to get to this. I had said I was going to pull on industrial relations, and one of the foundation books in industrial relations theory is Walton and McCursey's behavioral theory.
It's our gospel.
It is. It is. Everything comes back to behavioral theory in one way or another. And what I'm going to do is take this concept of intra-organizational bargaining and apply it at the systems level. Essentially, they say within any party, there can be lots of disagreements about objectives, about tactics, about the relationships that you want to have, ends and means. Internally, people can disagree, and that constrains or limits what representatives can do. In the Biomarkers Consortium, which I mentioned was one of our other studies, the Biomarkers Consortium is in the area of what's called personalized medicine, where for many kinds of cancer and other diseases, people are increasingly aware that you don't have a single kind of disease. You have lots of almost one-of-a-kind instances. And to really understand that, you need to understand what are called the biomarkers when cells change that tell you something bad is happening or even something good is happening. Insulin is a biomarker for diabetes. It turns out in the pharmaceutical industry, a couple of the big pharma companies had spent hundreds of millions, close to billions of dollars, trying to identify and qualify biomarkers that were the same ones that were all dead ends, but they couldn't talk to each other for antitrust reasons. And so that's what led to the birth of this consortium, which is a pre-competitive public-private partnership with big pharma, small biotech, universities, FDA, NIH, and patient advocacy groups, all working in a pre-competitive space to do research in biomarkers. And when we did the survey of the stakeholders, one of the qualitative questions was, do you have issues within your organization that affect your ability to work across with others? And you can see that they're saying, in order to be making decisions, I have to get people in my organization, get their ears tuned so that they can be part of it. It was helpful when my director was on the executive committee, because then I had some alignment internally to do things. That company reps couldn't speak for their company, so it limited what the consortium could do. Government reps didn't organize themselves, so it limited what we could do. And this was from one of the fellows in industry who said that, in fact, they had to form an internal council for all the people that are on consortia, because the institutional landscape of biomedicine is changing, where it's not just independent companies competing, but also these new consortia that are pre-competitive of various kinds, or joint venture partnerships. And so they had to internally align themselves to be part of these multi-stakeholder initiatives that are increasingly part of the institutional landscape. So that's qualitative data on the issue. Now let me move to some quantitative analysis. What I'm going to share with you are some very preliminary multivariate models in which we have some control variables for fields and disciplines, years of experience, gender, and whether they're an international or US-based setting. The first dependent variable is back to those three variables. I'll show them to you again for the internal institutional alignment to do lateral alignment. The second is a behavioral variable, which is these six categories. Are you involved in Earth Cube, with the higher number being higher levels of involvement? And the last one is a variable which I'll show you, which is how frequently do people interact with others across fields. So this, as a reminder, was those three: internal alignment for lateral alignment. That's the first dependent variable that we're going to use. The third one that we're going to use is we asked everybody, how frequently do you talk to people in these other fields or disciplines? And it was on a scale of 1 to 5, so these are the different means. And what I calculated was what I call my Garrison-Keillor measure, which is for each field, I got the people who were above average in their communications with other fields and disciplines compared to the ones that are not. And just to give you a feeling for it, Here's all the fields and disciplines on both axes, and needless to say, the diagonal is most of people are talking regularly to others within their field. This is the percentage of folks that are daily, weekly, or monthly versus quarterly, annual, or never. And then what you see here are that for atmospheric scientists, climate scientists and geographers are the next most frequent people that they talk to. That for oceanographers, it's biologists or ecosystems folks. And you can do this in different ways. But the point is that we're looking for the ones that are above average relative to the rest. There's a lot more analytics that can be done here because you can essentially see where the interdisciplinary potential is by those that are talking to a lot of folks versus those that are talking to relatively few. And that's, again, just the beginning of what can be done with this. But let me share with you some results. This is a simple OLS model. We think there's some structural equation work to do this that might even better specify it. But with this simple model, we have people under 5 years experience, 5 to 10, 11 to 20, and then the left out category is over 20 years experience. So these are the responses for the internal alignment relative to the one that's left out. And basically what it's saying is that the folks who are under 5 years or 5 to 10 years are saying that they actually have more support for talking, for engaging with EarthCube and doing this work than the most senior people. That's good news that they're getting support. On the other hand, the senior people are the ones that are reviewing grant proposals and making tenure decisions. And we're going to see that that's going to be an issue. For institutional affiliation, we see no effects, but for most of the other professions, what I did is I left out the computer scientist. So these are all the coefficients relative to the computer scientists. And what you see is that the signs are almost uniformly negative, and some of them are negative and significant, saying that most of the geosciences are getting less support for engagement with EarthCube than the computer sciences. And in fact, at the 200 people at the charrette, it was more computer scientists or computer literate geoscientists. And the risk there, and the risk that EarthCube faces is that it could be a case of build it and people don't come. Because the computer scientists aren't talking to the end users. And in fact, based on some of this work, they now have launched these domain workshops to get the voice of the customer from some of the folks within the disciplines, like the tectonics group. And now there's, I think, 14 more scheduled for the first and second quarter of next year. But this says that that risk is real. Then I did a second model, which is, are you actually behaviorally engaged with EarthCube? And what we see is that the folks that are the most junior folks are not. So it's the senior people that are designing EarthCube. But then the question is, are they taking into account the needs of the next generation? When we did the early career workshop, the main question that we asked people is, assume it's 10 to 15 years from now and you're having fantastic success. Describe to us the cyber infrastructure that's helping you to be successful. And what they had to say was not identical to what's currently being developed. And so we wanted to amplify that voice. When we ask people, are you engaged in EarthCube? What you see is there's some variation here. In my backup slides, I can show you, I actually broke out these responses on importance and ease, that gap that I showed you earlier, by clustering the geoscience fields into those that do array-based data, like big atmospheric data, versus physical sample data, single-point data, like rocks, and versus hybrids, like the hydrologists that use a mixture of the two. And it becomes very clear that the folks that do both array and physical sample are much more disciplinary-centric as compared to the folks that do a mixture of types of data. But what we see here is that, in fact, the internal alignment variable comes in strong, positive, and significant for EarthCube engagement. So those folks that have support for engaging are engaging. It matters. In fact, after the early career workshop, we wrote to the deans and department heads of all the participants saying, you should sit down with this person. It's a big deal that they were picked by a program officer as an up-and-coming star. Talk about EarthCube. We have our Garrison-Keillor measure. How much, forget EarthCube, how much do you frequently engage with people across fields of discipline? And what we find is that, in fact, It's the folks that have 11 to 20 years that are most frequently, in terms of talking across fields and disciplines. That's really the sweet spot where a lot of things are happening. Again, it's helpful to know the territory. Relative to the computer scientist, there's a couple of areas. The oceanographers are less likely to be doing this. The ecosystems folks are more likely, and interdisciplinary areas do emerge as sort of more interdisciplinary. Surprise, surprise. But at any event, this gives you just the beginning of a flavor of doing some multivariate analysis and suggesting that this key variable, internal alignment, matters, but it doesn't show up here for the behavior in general. And what we're interested to see over the next 10 years is, do we see this showing up over time as being an enabler for that cross-disciplinary communications? So just to summarize some of the implications from the model, early career scientists perceive more support than the senior scientists, but they're less engaged. So are we going to create something that won't meet the needs of the next generation? I didn't focus on it, but the international scientists show up on this analysis and some of the other charts that I had as much more interdisciplinary in nature. So it points to the importance of that. The issue of the build it and they'll come is a risk that this data reveals. And we do have support for the notion that internal alignment does enable lateral alignment, but it doesn't yet show up in terms of frequency of interaction, something to track over time. So just to wrap up, Ralph Cicerone, the president of the National Academy of Sciences, former head of the NSF, said that today's most troubling and daunting problems have common features. They arise from human numbers, they need long-term commitments, there aren't simple unidimensional solutions, and failure can lead to disasters. He also says that the scales and complexities are unprecedented, the solutions will likely be iterative, and importantly, he says the institutions can enable things that individuals can't. So to conclude, I promised that this would be a look at first principles for stakeholder alignment in complex systems. So here's my first list of 5 first principles. The first one is that it's easier to be negative, and it's a recipe for gridlock. The second is, in any complex system, you need to be able to specify the stakeholders. In any complex system, you need to be able to identify the interest, and by putting them together as a matrix, it allows you to do alignment, the visualizations that can accelerate alignment you can accomplish in 3 to 5 years, which might otherwise take 5 to 10. And lastly, some support for this initial notion of internal alignment for lateral alignment. So finally, the National Academy of Engineers also identified the top challenges for the 21st century. And I would argue that you can look at every one of these and see gaps in stakeholder alignment and importance in building institutions that are agile for the 21st century. Thank you very much. So I think we have a few minutes, right?
Yes, thank you. I think we have probably enough.
Okay.
10 minutes.
By the way, I have additional regression results that are fun to share and other findings that I can share with you, but let me see what your questions might be or comments.
If I can start?
Yeah.
I think you present this Z flower.
Yeah.
Which is a powerful display of the result. I'm just curious because I'm guessing because you're talking about alignment. That's why you choose the mean to be at the center.
Right.
What if depend on your decision objective? Could there be any other value? For example, I could easily choose the maximum value to be at the center to see how far, how spread out things are going to be. Or I just want to know what are the general principles to choose what to be at the center and then corresponding to what kind of decision problems.
That's a really nice point. We are designing a user interface so that people can look at the data themselves and to order things in different ways. We're also developing the ability to calculate the Z-flowers on handheld devices. So stakeholders can ask a question of other stakeholders and instantly get back a visual map. And we've already talked about a couple of different palettes and different, like one for colorblind and other kinds of things. and other ways that you can customize use of it. Your point, which is to make the center point of the Z-flower not just a mean, but maybe one standard deviation above the mean, or a high-end extreme or a low-end, and then have everyone's views in reference to that reference point, could be very useful for certain kinds of issues and certain kinds of decisions. So the point is that how you visualize and display the interest then is meant to help the parties, the stakeholders, find their way forward, to see things that they wouldn't have seen otherwise. And so having more than one way to define the center could be really useful. So, nice point.
What about the connection between what you're doing in social networks? Because in a lot of ways, this is clustering different stakeholders and trying to find distances.
Yeah. So one of the studies, which one of the people on the team is Barbara Lawrence from UCLA, and she's done some very interesting network analysis with the others in organization, which she calls the they. Most people have social networks that are a very small group of people, but then there's a whole large group of others or they that are out there when you say they won't let me do it or they would like this. And she's trying to get at that. What we've done with the early career workshop, so 150 people were invited, 76 came. It's a perfect natural experiment in which they're all identical in having all been invited. Before the workshop, we asked all of the people that were invited, who do you know among the people who are coming? Immediately after the workshop, for the 76 that came, we asked them, who do you think you might want to work with and do collaborative work? And for a year, we're going to be tracking them using network analysis tools to see what the emergent interdisciplinary network is that might be a foundational piece for where some of this breakthrough scholarship. And already at the workshop, people were saying, you're doing that? Well, I need one of those to do this. And exactly it was happening. But the answer is, most social network models assume that individuals are the centroids, that are the nodes that you're connecting. We're saying that stakeholders, which could be individuals or groups of individuals, are the nodes. So it's almost networks within networks.
You could use some of the same tools, some of the analytics
Absolutely.
I think would work.
In fact, one of my former colleagues from Illinois is now using data as a node in a network, in which so we look forward to sort of bringing that network lens. Most network modeling tools don't have. There's some analytics that are out there. There's a lot more that could be done. I'd like to be able to do a mixture of the network modeling and modeling that gets beyond just one dimension or two dimensions of communications. That's typically what's modeled to all of these other interests that are at play. So I'd love to be able to combine them. Yes.
Enjoyed the presentation very much. A couple of comments. You've already acknowledged one thing, that you haven't yet taken account of power, authority, influence in the model. And if you can build that into the model, I think in the end you'll have a more powerful model. Second comment, I think this is, it's too bad, I don't know, does Bob McCursey must know about the work.
Oh, yeah. He's delighted.
And he's delighted. And it seems like a classic example of what Walt McCursey always talked about is sort of mixed mode of decision making.
Yes.
And this dilemma between collaborating or cooperating on the one hand, or competing, or as game theorists would say, defecting on the other hand. I think there's this dilemma built into your analysis, into the data. And I might go so far, I don't know whether this would be strictly speaking the case, but it almost seems like these scientists are in the middle of a prisoner's dilemma. And that is, and maybe especially for younger people, I'm not sure, but I want to publish, I want to keep hold of my data. There's a strong incentive not to share.
So everyone will say, I want to live in a world where everyone shares their data so I can do the most interesting cross-disciplinary work, but I don't have the time to do so.
So the dominant strategy takes you to defect.
Right.
And what you want is, the inferior strategy is cooperation.
Right. So when we did the early career workshop, one of the world's leading geoscientists who was part of the design team for that workshop, Bob Hazen, did a presentation on what he called brute force analysis, in which he showed how they were able to identify where mercury deposits are on the planet, which look different than other minerals, because about 600 million years ago, we had a sulfuric ocean, and mercury binds with sulfur, so it didn't get deposited during that juncture of plate tectonics. And he said in order to be able to put together the different data from different fields and disciplines to do that study, it took teams of graduate students 3 years of hand-coding observations from Russian journals from 100 years ago and all sorts of odd and different sources. And so it was brute force. And the question is, could you have that exist in a data set so that people could just say, all right, I want the Z chronology measures for mercury and bring that in easily? The answer is that, and this is what I think what motivates this, is that it will actually take changes not just in the physical, technical infrastructure, but in the institutions and the rules of the game, in the incentives, in the forums, and all the mechanisms. And so the work that we're doing with the NSF is basically, they were marching down a build it and they'll come kind of technology trajectory, and now the whole conversation has shifted to a both end. Yes, it has to be that, but how do we engage the universities? How do we engage the different parties to talk about career paths and talk about some of these other factors that will, fundamentally impact the ability to do this? Yeah.
A lot of the discussion has been kind of framed in terms of incentives.
Yeah.
I wonder, from a couple perspectives, about the idea of transaction costs. And there's a whole neo-institutional economics has really brought that into the forefront, and I see that as, I see in some sense the EarthCube project as being a way, if and when it's successful, if I understand it correctly, it's a way of reducing transaction costs after it's in place.
So let me share with you two things about that. You're right on the money. First, this is a chart that I put together on a precursor, a parallel initiative in plant biology like EarthCube. It's about 4 years old, and you see there's just this huge increase in users that's happened. Partly they were doing tool building at this stage, but the bigger thing is that the plant biology world got taken over by plant genomics as the place where all the action is. And it turns out to do genomic research, you need large pool supercomputing resources. And so the number of people who voluntarily are serving on committees and helping to support iPlant has gone way up because they need the common pool resource. So some of it is, you avoid the tragedy of the commons because the commons is suddenly more valuable. And in fact, you realize it's essential to your work. So some of it is, if we look across the geoscience fields, we see differences across fields and disciplines based on the need for common pool resources. But there's another piece, which, actually I think I'm going to go this way. Here. Some of you may know Kurt Lewin, who developed this idea of force field analysis, that in any systems change, there's driving and restraining forces. And this is a kind of cartoon force field analysis for the geosciences. So the need for interdisciplinary innovation is partly driven by the urgency of climate change, partly driven because they're interesting questions, partly because the agencies, every NSF solicitation calls for this interdisciplinary work, by the way, calling for social scientists as well, most of whom aren't forthcoming, which is a whole conversation we can have. Most universities say we need to make a difference in society on these big grand challenge kinds of issues. People are open to collaboration, but okay, so here's the barriers. There's real complicated interoperability issues with the different kinds of data that are involved. There are these career development issues. The conservative process for publication. There's the tendencies of people to only work with people like themselves, homophily. The basic human tendency for risk aversion. The big insight from Kurt Lewin is that when you're trying to drive systems change, if you push harder on the drivers, you don't necessarily get more change. But if you reduce the barriers, not only do you lower a barrier, but you often create a driver. So if the barrier is the lack of credit for sharing data, and you create a citation index that tracks that, you've created a driver. So I think that the basic answer to your point is that you need to focus on the barrier side. You need to focus, because the intrinsic value of this will drive it by itself. And so you're absolutely right. Well, I see that we're at time.
That's a very, very nice talk. So here, system, we have this for you, Thank you. And let's thank our speaker again.